All right, so let's go on to the second part. Second part starts on bottom of page 97. We're looking at transforming data. Okay, so let's say, let's go back to the test that we just did. Okay, we had an average of 62%. Okay, and so I'm feeling kind of bad. I think you guys might get demoralized. So this is not ever going to happen, but in your dreams, I decided to add 20% to everybody. Okay? So what happens if I add 20% to everybody? This now goes where? What happens to this? What does this become?
82.
82. So in other words, now the new one is going to be at 82%, right? 82%, all right? And this guy that was over here is going to be over here, correct? 20%. This guy that was over here is going to move over here, right? And I'm going to look like, well, I can do better than that. I'm going to look like that, right? So what happened to the shape? What happened to the shape of the curve? The shape of the distribution? Did the shape change?
No.
It's exactly the same shape, right? I just went ahead and shifted it over 20%, correct? Right? What happened to the center? The center that was 62% is now what? 82, right? I added whatever it is I added to that. So that's gonna, the center shifted that way, right? What happens to the range? Did the range get larger or smaller?
It's the same, right?
It's the same, right? So the range is the same. The IQR would be the same. The standard deviation would be the same, right? Because the shape is essentially the same. Okay, so anything that has to do with spread never changes, right? The only thing that changes is that you added 20% to the center. Okay, so if you go to page, where's that at? Page 98, bottom of page 98. Go ahead and read that green box for me. The effect of adding or subtracting a constant. Okay. And if you added the number A to every data, okay, it adds A to the measures of center, whether it's mean, whether it's the median, or whatever it may be, okay? Does not change the measures of variability, so your IQR, range, standard deviation, all stay the same. Does not change the shape of the distribution, okay? All right, so that kind of makes sense. It's not that hard, right? Let's look at the example. If you look at the example, it says effective adding or subtracting. Go ahead and read the problem to yourself, because I don't want to sit here and read the same thing. Go ahead and read it. Okay, so everybody guessed how wide the room is, which was 13 meters, and they did a distribution. So you see the distribution there. There's A, what shape does the distribution of the error have? So once you have subtracted the 13 from the guesses, the shape is going to be the same because you just subtracted the number. The shape itself is not going to change. It is still going to be skewed to the right. B, find the mean and the median of the distribution of the error. Okay, the mean and the median used to be what? The median used to be 15, so the error is going to be what? 15 minus 13, so it's going to be 2, correct? right? The mean was 16.02. Now it's going to be 3.02 because all you did was subtract 13 from that. C, find the standard deviation and the IQR of the distribution of the error. Okay, the standard deviation, it was 7.14, so it's going to still be 7.14. The IQR is 6, so the error IQR is still going to be 6. Okay, so that's what happens when you do that. So actually, that's what happens when you do that. Let's go ahead and see what happens if I multiply a number to each of them. Okay, so let's say that I had the curve that we had before that looked like this. I had 62%, and I decided to, instead of adding 20, I'm going to multiply it by 1.2. Okay, if I multiply it by 1.2, okay, what's going to happen to the shape? So when I ask this question, the thing that you should be thinking in your mind is that if I had a skewed to the right distribution, does it all of a sudden become skewed to the left? Or if I had something that was roughly symmetrical, does it go from roughly symmetrical to be skewed to the right? Okay, so that's not going to change. Okay, so again, the shape is not going to change when I multiply it by the same number. Okay, what's going to happen to the center? The center is going to be multiplied by whatever the number you're multiplying it by, correct? All right. What's going to happen to the IQR and the standard deviation, that kind of stuff? What do you think is going to happen? Does it get larger or smaller? Let's say that I had a Q3. Here my Q3 was, I don't know, 75, and Q1 was, I don't know, let's say 55. Okay, so I multiply these by 1.2 and 1.2. What am I going to get? I'm going to get something here, right? So if I subtract this, that would be the IQR. The IQR here was 20, right? So the IQR over here is going to be 24. Can you see that's going to be the IQR is going to be 24 now? Right? All right, somebody pull out the calculator. What is 75 times 1.2?
90.
90? What is 5 times 1.2?
66.
Oh, 66. So if I subtract that, I get 24, right? Because the original one was 20. The IQR was 20. I multiply that 1.2, I'm going to get to 24. Okay, so IQR is going to be multiplied by the same number. Okay. Similarly, the standard deviation gets multiplied also. Okay. So if you go to page 100 in the middle, there's a green box that says the effect of multiplying or dividing by a constant. If you multiply or divide each observation by the same positive number b, it multiplies the center, the location, so the center all gets multiplied over here, just like we said here, okay? All right. You multiply the variability, so the range, the IQR, the standard deviation, but does not change the shape of the distribution. Okay, so what was skewed to the left does not become skewed to the right, or what was roughly symmetrical does not become skewed to the right or anything like that. The shape also stays the same. Okay. Any questions there? Any questions? No questions? Okay. Let's go ahead and do the example. How far off were our guesses? Okay, so let's go ahead and do that. So let's go back. So they're referring back to the preceding example where the width was 13 meter and everybody was trying to figure out what it was. And we came up with a new thing, new distribution called the error by subtracting 13 from each one of them. Okay. Because the students are, okay. To change, so it's roughly 3.25. So all they're doing here is changing the units, okay? To change the units of measurement from meters to feet, we had to multiply each of them by 3.28. So in other words, you're multiplying everything by 3.28. A, what shape does the resulting distribution of the error have? It's the same that we had before, right? This is going to be skewed to the right because the original one was skewed to the right. B, find the median of the distribution of the error in feet. The original median was 2. So you're going to multiply that by 3.28 to get 6.56. C, find the IQR of the distribution of error in feet. So the IQR originally was 6. So you're going to multiply that by 3.28 to get 19.68. Okay, and I'm not going to do the last example. And we are done. Are any questions? So let's go back to page 91. Let's go back to page 91. And the top of page 91, there are learning targets. So let's look at our learning targets. The first one, find and interpret the percentile of an individual value in a distribution of data. Okay. So how do you find the percentile? How do you find what is the definition of a percentile? Okay, you always have to talk about stacking them up from smallest to highest, right? Smallest to highest, and you say the percentile is that if that person stood up, how many percent would be behind him? Okay, that's the percentile. Second one, estimate percentiles and individual value using a cumulative relative frequency graph. Cumulative relative frequency graph, again, is going to look like this. 100%. So to find the percentile, if I wanted to find the 60 percentile, I would go 60, and I would just go ahead and read it off right there. Okay, that's how I would do that. Okay. The next one says, find and interpret the standardized score, Z-score of an individual value in a distribution of data. How do we find the Z-score? The Z-score was taking your individual data, whatever that data point was, subtract from that the average, divided by the standard deviation, right? This was the Z-score. Last but not least, describe the effect of adding, subtracting, multiplying, or dividing by a constant, the shape and the center and the variability, okay? I'm not gonna go over that because we just went over that. You guys should know that. All right. Let me go ahead and